Good afternoon, guys. So we're going to be talking about domain and range today. And those are words that I know that you've heard before, but it seems like nobody can ever actually remember what they mean. Okay? So let me give you kind of another way to think about domain and range that I think will help you remember what they mean. Think about when you go to your mom or your dad and you say, "Hey mom," or "Hey dad, can I go hang out with my friend tonight?" And they say, "Sure, but you have to be back by midnight." Well, then midnight's your boundary, right? So you could come back at 8 o'clock. You could come back at 11. You could come back at 11:59 and 59 seconds and still be okay. But if you come home past midnight, you're in trouble because midnight is the boundary, right? Domain and range are the boundaries of a graph. They tell you where the graph is located. It can't go past this point. Okay? So with that in mind, what type of boundaries are domain and range? Well, domain is your boundaries on the left and on the right. So think about on a graph, which one of those axes goes left and right? Well, it's the x-axis. So what domain tells you is what is x allowed to be. It can be anything between here and here, but it can't go past those points. Okay, that's my domain. Another way to think about it, if we're thinking about a function, is your domain tells you what your input values are. So it tells me what am I allowed to plug in the equation for x. Your range, on the other hand, tells you what your boundaries are up and down on the top and bottom of that graph. So another way to think about that is it tells me what my y values are allowed to be, or what my output is. Okay? So with that in mind, example 1 says give the domain and range of the graph below. Well, remember, domain is my boundaries on the left and on the right. So I'm going to find the point farthest to the left on this graph and put a little mark there. There's the farthest to the left. Well, what is that I just put an X on? It happens to be an arrow. What that tells me is as I go to the left, that graph is going to keep going forever. So what's happening there, I put a D for domain, is it's going to negative infinity. Then I say, okay, what's happening on the right side? I put an X on the point farthest to the right. Well, on the right side, it's also an arrow, which means it's going to keep going forever and ever and ever as long as I want to graph it to the right, which means on the right side, it's also going to infinity. So what does that mean? Well, in this case, as far as the domain goes, we don't really have a boundary. I could keep graphing this thing as long as I wanted to, and it would keep getting wider. Another way of saying negative infinity to infinity is to say this right here. You can say all real numbers. So x could literally be anything. It's going to keep getting wider. What about my range? Okay. Well, for range, I always start with the bottom first. So here's the lowest point, right here. And here's where I have to be careful. I realize there's a 2 right there where I put that x. However, 2 is my x value, not my y value. Remember, I'm talking about up and down. So right here, if I'm talking about up and down, the lowest spot that I am up and down is not 2, it's 0. Okay? Then I go and I put an X on the highest point on this graph, which is right here. Well, what's happening at that highest point? I have an arrow again. And since that arrow is pointing up, it's going to positive infinity. So something I want you to notice here. Notice how on the infinities I put parentheses because they're not actually a number. However, on 0, because 0 is actually a point that I can pinpoint on the graph, it got a bracket. There is a spot where this graph is actually equal to 0. There is nowhere where this graph is actually equal to infinity. Infinity is just a symbol we use to stand for it goes on forever. Okay? So this is what's called interval notation when I use the brackets or parentheses. If I don't like to write it with brackets and parentheses, I can also say this. I can say y is greater than or equal to 0. So think about it this way. I'm saying y could be 1, it could be 3, it could be 4, it could be 1005, as long as it's greater than or equal to 0. Okay? So there's my domain and range. What about example 2 now? Example 2 says give the domain and range. So for the domain, I start by putting a little mark farthest spot to the left, and that's right here. Well, how far does this thing go to the left? Because that's not an arrow. Well, it starts at -2. It doesn't go any farther to the left than that. But what about on the right? Here's the point farthest to the right. Well, on the right, I have an arrow. It goes on forever. So that's a positive infinity. So anytime things are pointing up or to the right, you get a positive infinity. If they're pointing down or to the left, you get a negative infinity. So there's my domain. Okay? If I don't like to write it with the brackets and parentheses, I can also say x can be anything as long as it's greater than or equal to -2. Okay? Now let's look at your range. So range goes from top to bottom. So I always start with the bottom first. Here's the lowest point on that graph. And it's an arrow again. Well, what does that tell me? Well, first of all, it's going to infinity. But because that arrow is pointing down, it's going to negative infinity. What about my highest point? Here's my highest point. Okay? And again, think about it this way. I realize there's a -2 there. But that -2 represents how far to the left we went. It doesn't tell me how far up and down I went. So how far up did I actually go? What's the y value at that point? Well, it's 0. Okay? Another way to think about it is this. The coordinates of that point are -2, 0. -2, the x part, goes with my domain. The y part goes with my range. Okay? If I don't like writing it with parentheses and brackets, I can say y is anything less than or equal to 0 this time because it's pointing down, so it's a less than or equal to. All right, what about example 3 here? So this is a cube root function. Hopefully you recognize that because we've talked about them before. So domain, I start on the left, and I have an arrow. Well, that tells me I'm going to negative infinity. Then I go to the right side. I have another arrow. Well, that means I'm going to positive infinity on the right. If I don't want to write it with the infinities, I can say all real numbers. So this thing will keep going left and right forever as long as I want to keep graphing it. There are no boundaries. What about my range now? Okay, I start with the lowest point. And again, the lowest point is an arrow. And that arrow happens to be going gradually down. And I should have put a R there instead of a D. So your range on the bottom is going to negative infinity. Here's the highest point. And again, it's an arrow, so it's going to positive infinity. So on this graph, what that means is there are no boundaries. If I kept graphing it, it would keep getting taller. It would also keep getting wider. Okay. All right, example 4. This will be the last one we do with a picture here. So for my domain, okay, again, domain is left and right. Here's the left, right here. It's an arrow. Because it's on the left side, I have negative numbers on the left side, so I'm going to negative infinity. Here's the point farthest to the right. Well, on the right, I go to positive infinity. And again, we're thinking in terms of left and right. I realize that arrow is pointing down. But if we're talking about left and right, as I go farther to the right, my numbers get positive. Okay? What about the range? Well, I start with the bottom first. Here's the lowest point, right here. And again, it's an arrow. And since I'm going down, it's going to negative infinity. Okay? Here's the top part. And the coordinates of that top part are -4, 3. So my question now is, if I'm dealing with range, which one of those numbers tells me how far up I went? Well, it's the 3 here. So the 3 is the part of my range that I write down. I don't write down -4 if I'm dealing with range, because that -4 doesn't tell me how far up I went. It tells me that I went left 4. Okay? So there's my domain, there's my range. And again, if I don't like writing it in interval notation, I can call the top one all real numbers. And I can say for the bottom one, y, because I'm dealing with range, is less than or equal to 3. Because it's anything below 3. Okay? Very last example that we're going to talk about, this one they don't give me a graph. So what can I do? Well, if you've got a calculator at home, a graphing calculator, you can definitely type it into that. A quick website you can use that we've talked about before is you can go to Desmos, and you can do this right here. You can type in, as soon as it loads anyway, you can type in y equals, parentheses, oop, it missed my equals, equals, parentheses, x plus 1 cubed. Let me find my cubed here. There it is. Minus 5. And we'll scroll down so you can see this graph a little bit. So there's my graph. And again, I'm going to imagine that I have arrows on the end here, okay? Because this graph would keep going forever as long as I wanted it to. So I'm going to put arrows. If I want the domain, I start by putting a little mark on the spot farthest to the left. Here it is. It's an arrow, so that means on the left I'm going to negative infinity. What about on the right? There's the point farthest to the right, and it's another arrow, so that's a positive infinity. Then I do my range. Here's my lowest point right down here. Well, again, it's an arrow, so on the bottom it's going to negative infinity. On the top, again, it's an arrow, so it's going to positive infinity. There's my domain and my range. So if they don't give you a picture, go to Desmos and imagine you had arrows on the end. Look at the picture and give me your domain and your range. Okay? All right, and that is the end of our video.